The UN Standard Development Goals, or SDGs, are a list of 17 goals which attempt to take on social, economic, and environmental challenges by 2030. SDG number 7 is to ensure clean and affordable energy for all. Nuclear fusion is a promising solution for SDG number 7 because it offers clean, abundant, and sustainable energy. Fusion harnesses energy through fusing atomic nuclei, primarily hydrogen isotopes, and the energy released is converted into heat. This process is safe, minimizes radioactive waste, and does not contribute to greenhouse gas emissions, aligning with the goal of sustainable energy for all. The two typical isotopes used are hydrogen-2 and hydrogen-3. The resultant helium atom has less mass than the sum of its two isotope components. This missing mass is what is converted into energy in the fusion process. Before the two isotopes fuse, they are in a plasma state because their electrons are stripped away. Plasma is extremely energetic and unpredictable and needs to be contained by very strong magnetic fields in order for the isotopes to undergo the fusion process. There is currently a negative stigma about nuclear energy, and the public has the overall view that it is a greater risk than a benefit. This, however, is only limited to nuclear fission, which is the counterpart of fusion. Instead of harnessing energy from the combining of atoms, fission harnesses the energy from a heavy atom, splitting into two lighter ones. This reaction is harder to control and can lead to a nuclear meltdown, as it has in the past. Fusion, however, is completely safe, and as soon as the fuel supply is cut off, the reaction stops almost immediately. There is also little to no radioactive waste produced as a byproduct, unlike fission. Our own sun, along with every other star, actually uses the fusion process itself to create energy. Its immense gravitational strength and heat are the perfect high-energy condition required for fusion to occur. The efficiency of nuclear fusion reactors are improving rapidly. The first net gain in energy occurred in 2022, and since then, it has occurred another 4 more times in experimentation. Over time, nuclear fusion will only become a more efficient energy source. Currently, tokamaks and stellarators are the two main types of reactors used. However, there are some newer methods. Researchers currently speculate that the output of energy can be up to 30 times its input through a new process called laser fusion. Laser fusion is a relatively recent development in which the fuel is packed into a small capsule. The capsule is then shot at by lasers until the pressure and heat in the capsule builds up enough for fusion to take place. Laser fusion is also very versatile, as it can use fuels other than hydrogen. It is only a matter of time, most likely a couple of decades, before fusion replaces non-renewable energy sources and begins powering your homes.